Hi guys, it's Mr. Dave with the RayKitty Creation Workshop, and you are watching the RayKitty Science Project. Thank you guys for checking us out. We're going to be doing some fun science stuff today. We are going to be working a little bit with the Newton's laws of motion, which are kind of how things interact with each other, whether it's the air, whether it is a baseball or anything, the way that it interacts with something else and the energy that it uses and the way it moves. So these are the laws of motion. Now, these laws are pretty basic, okay? If you've ever painted, you have your kind of primary colors. So these three laws we can picture to be our primary colors or our primary laws. Meaning, if you mix them together, you have different things that happen, just like you can get beautiful, wonderful colors if you end up mixing those colors together. If you're braver than I am, I usually just buy them and use what I have. But if you're braver than I am and you mix those colors, it's the same way as with these laws. We can see wonderful things begin to happen when you combine these laws. When we're showing them here, we're going to start with just kind of the primary and basic idea, and we're going to start with that law 1. Now, Newton's first law of motion is that an object at rest tends to stay at rest. An object in motion tends to stay in motion unless they're acted on by an external force, okay? Now, what that means is if you've ever tried to wake your father when he's sleeping on the couch, he is an object at rest. He will tend to stay at rest, okay? When you wake up a child, they become an object in motion and they don't stop moving, okay? So it's kind of that idea. Once something is moving, it's going to want to stay moving. Once something's sitting still, it's going to want to stay sitting still. So we have some things here that are pretty common that you've probably seen this experiment before, and we're going to take it into some different areas, and then we're going to get into some ones that maybe you haven't seen before. So our first one here with that Newton's first law is going to be an object at rest tends to stay at rest, okay? So for this one, I have a cup. I'm using a plastic cup because I don't want the things falling in it to break my cup, but because this plastic cup is pretty light, it doesn't have a lot of mass, right? And we're going to talk about that when we get to our second law of motion. But because this cup is light, I'm going to put some water in there, okay? So I'm going to put some water into this cup, and that's just to give it some weight, okay? So as I'm filling up this cup here, it's getting heavier, okay? And that is creating more mass for this object that's at rest, okay? So this object is at rest. I have got here a pie tin, okay? Unfortunately, I don't have any pie in there because I haven't made a pie yet, and I'm terrible at baking. So hopefully maybe my daughter can make me a nice pie for this one, or my dad. He's really getting into baking. So for this one, what we're going to do is I have a toilet paper roll, okay? I have a paper towel roll, and then I have this little one that I made myself. Now, this one really is kind of the same thing, this tube, but the reason I made this one myself, and if you're doing this at home, I just got a piece of thicker paper, kind of like cardstock, and I rolled it up and I put some tape on there. Okay, so you can see the tape here, it's just rolled up. The reason I made this one is you'll notice that it has a smaller diameter. It's smaller around than these ones here. Okay, these ones are readily available. You probably have them all over the place. Make sure they're clean. These ones here, again, readily available. But you'll notice if I'm doing it with a ping pong ball, that ping pong ball is going to fall right through. So we don't want that, and that's why I made this narrow one. There's no magic to it. It's just a roll of paper, okay? So if you're doing this one at home, there's a lot of different materials you can use, but you've got that toilet paper roll. A lot of times people will do it with an egg because it's a little more dramatic, but I didn't want to have to clean up an egg today. So I'm going to be using some other objects. I have a golf ball. Okay, I have a ping pong ball. This one has a little fly on it, so this one is a fly ball. And we were, the wonderful folks at Catharsis, we were joking about this one a little bit earlier. And I've got the world. Okay, it's not this is not actual size. Okay, but I've got these different things that we're going to try with the same demonstration, and we're going to show a couple different principles before we go on to some of our other demonstrations. If you're doing this one at home, as I said, I'm using a plastic cup. You can use a glass, but be careful if you are using a glass, because sometimes if you've got heavier things falling in there, it can do damage. So I recommend a plastic cup. I'm using a pie tin, but you can use a styrofoam plate. You can use a styrofoam tray. You can use a pie tin. Really, just about anything that you can kind of whack and it not crush too bad, and that is stable enough to hold up what we're going to put on top. Okay, so there's a lot of different things you can use for this one. This one, there's no real specific materials you need. So we're going to start out with our little toilet paper roll here, and I'm going to set it on top. Now, if you're doing this one at home, you will want to make sure you're pretty level with your cup. Okay, so you want that. I put the pie tin about centered in the cup, and I put my little toilet paper roll right on top of that cup, okay? Because our goal here is to show that an object at rest tends to stay at rest, okay? So this little golf ball here, oh, another thing I was doing, here's a little trick. The golf ball sits in there pretty tight, okay? So on my toilet paper roll, I squeezed it just a little bit. If you've ever been in any of the RayKitty classes, the scientifical term, which means not a real word, but the scientifical term is to squeeze that, okay? So I did squeeze it just a little bit, and I did that so that ball sits a little bit higher on our roll, okay? So we can see that it's not quite stuck in there. Now I'm going to move some of my other objects over here for just a little bit, so that my pie tin doesn't send them sailing off into the ends of the studio over here. Now, this one, as I said, maybe you've seen before, we're going to take it in a couple different directions before we move on. Okay? Now, what we want to do is we want to remove the pie tin, we want to remove the toilet paper roll, and we want the little ball to drop right into the water. Okay? Now, when it does, we want to see if that ball is moving this way or that. But right now, this ball is at rest, okay? So we're going to have to apply, when we're doing this, you want to apply pretty good smackage, okay? Another scientific term. But what you're going to want to do is you're going to want to hit this with some force, okay? Because that's that second law, which is the velocity, okay? So we're going to want to hit this with some force, enough force that these go out of the way, and they leave our balls sitting in the air, okay, which another force is now going to start interacting with our ball, and that's gravity, okay? So the gravity will bring the ball down and hopefully land in the cup. If not, I will chase it as it tries to roll off the table. Now this one here, if you're doing it again at home, it may take a couple tries. It won't work every time. That's the fun of it, okay? And we are going to do some experimenting, so kind of add to it. If you're doing this at home, get mom or dad or brother, sister of your family, get all of them around, and everybody try and make kind of a challenge out of it, because I am going to show you a challenge with these in just a minute. Okay, so let's get to whacking this thing. So what I'm going to do is I am just going to slap it. Okay, now when you slap it, try not to slap the cup underneath, or else you're just going to knock water everywhere. So what I'm going to do is we're going to watch this ball, and I didn't hit it the right way. Okay, here we go. We're going to watch this ball and see if I can get that ball to fall right into the cup. Okay, are you ready? Okay, here we go. 1, 2, 3. There you go. Very simple, right? The ball, because it has more mass, because it's heavier, was able to stay here and get knocked into the cup because everything else moved out of the way. Okay, so when everything moves out of the way, that ball is now got gravity and it falls into the cup. Okay, that's a simple one. That's an easy way to start, but you're probably going to want to step it up a little bit. Okay, so one of the ways you can do that is see how high you can get that ball. Now, I've got this one here. We'll see if we can do it. I've got it on this paper towel roll. Now, we didn't have much distance there, but now we've got a lot more distance, a lot more room for that ball to fall. So we're going to try it here, and we'll see if I can whack that thing enough to where that ball falls in there. Now, this ball is heavy, and these are both very light. Okay, so we're going to talk about that second law in a second, and we will tell you kind of one of those things that's happening. So I'm going to hit this thing here. Ready? Here we go. And 3, 2, 1. Whoo, nice. All right, so that works about half the time. So I'm really glad that one worked. Now, because this ball is nice and heavy, we're going to talk about Newton's second law, okay? Because as I said, these laws, we have more than one that are kind of affecting our project here. One is an object at rest, okay? So while this was at rest, we didn't have a whole lot of force on the ball. All we really had was this little paper towel roll kind of twisting the ball a little bit, but when gravity kicked in, it was able to move it. Gravity was a stronger force. Now, the mass, okay, the second law of motion is that the mass plus the velocity equals the force, okay? So what that really means is if something's nice and heavy, this golf ball is pretty heavy for its size, okay? So because it's heavy and these are lightweight, we were able to hit this, okay? This does not have a whole lot of mass, okay? It's way larger, but it doesn't have a lot of mass. It's very light. The same with the pie tin, it's very light. So these were able to move because they didn't have a lot of mass, and all of this mass here tended to stay at rest, and so the mass here didn't have a lot of force, didn't have a lot of velocity until gravity kicked in. Okay, so we see that with this with this golf ball that's nice and heavy. We're going to change it up just a little bit here, and I am going to use a ping pong ball. Okay, now when I get our setup here, I do want to switch over to my blue one. Remember, my blue one, this is the one that I wrapped up. It's just a wrapped up piece of paper with some tape on it. When we're using this one here, it is a lot smaller. So we're going to see about this ping pong ball, okay? Now, remember that second law. We have not a lot of mass here. This is about the size, it's a little bit smaller, okay? But it's close to the same size as our golf ball, but because it's hollow, there's a lot less weight, there's a lot less mass, okay? So with a lot less mass, we're going to see what happens. Now, with this one here, like I said, that other one, you're at about 50% where this one works. If you're trying this one at home, this one's a fun challenge because you're probably about 25% of the time that it works, okay? But that's also what we're demonstrating is that change in mass. This is a lot lighter. So I'm going to do the same thing. I'm going to whack this, and we're going to see if that ping pong ball goes with everything, okay? Because there's not a lot of mass, so it's following it. Or we're going to see if it stays put. So let's see what happens when we do it with a ping pong ball. I'm going to turn it over here because this one has a fun little design on it. There you go. All right, so here we go. Ready? Same thing. 1, 2, 3. Nope. Okay, what happened there is if you're watching this and you can slow it down, you will see that when this thing moved here, there was not enough mass to keep it still. So when this rotated, we saw it just chucked this little ball off of there. Let's try it again. I'm anticipating the same thing, that ball will not fall in there. And that's what we're showing is that this one has very little mass. And so that Newton's second law is that this thing is just going to move all over because there's not enough mass there to have that force. So let's see what happens. 1, 2, I don't know why I count down when it's just me. Okay, but you guys are watching, so you can count down, and that way you'll know what happens. All right, so here we go. Ready? 1, 2, 3. Oh, hey, I did get it. I did get it. All right, so I'm going to quit that particular one on a win because I'm pretty proud of myself. But this one here, as we saw, even then, we did get that twist. We did end up landing in the cup, so yay me. But this one here has got a lot less mass. We're going to switch it up with the baseball. Okay, so I've got a baseball now, which is considerably heavier, okay? So judging from what we saw there, right, we saw the golf ball stayed, okay? We saw that the ping pong ball had a tendency to go with that tilt, right? It was a lot easier. So what do you think is going to happen with a baseball? Okay, what's probably going to happen, or what I'm hoping is happening, is that this baseball will fall right in the water, and when it does, it'll probably end up splashing on me, okay? So if it does splash on me, don't laugh. Okay, You can laugh, it's okay. All right, so we're going to try it with a baseball, and we're going to see what happens and see if I can get it in there with this baseball. All right, so we're going to see if we can get everything lined up. Like I said, when you're doing this one here, make sure that everything is lined up, because the better it's lined up, the better you're going to, the better chances of it landing in there. Okay, so we're going to give this one a couple shots because I want to see what happens. We're going to see if we can get that baseball to dunk in the water. A lot of weight, a lot of mass. Okay, so with all this weight and this mass, we're going to see what happens. Okay, I'm going to count even though it's just me. All right, here we go. Ready? 1, 2, 3. Nice. All right, so we were able to actually get that thing. I only got minorly wet, so that's not too bad. But we were able to dunk that baseball because that thing had a lot of mass to it. Okay, so that demonstration there is showing a lot of that first and second law. Now we're going to get, here's a quick one, or just a quick way to kind of take this one home and challenge your friends. This is one that is kind of going around on the internet a little bit right now. And so it's kind of a fun one that you can do with your friends, because anytime you can turn science into a challenge, all of a sudden it's way more fun. That's how things like the water bottle flipping and all of those kind of took off. So this one here, what this challenge is a penny stacking challenge, but we're going to use this card here. Okay, you can use any playing card, you can use a business card, you can use a like a 3x5 card, whatever it is that you find, but we're going to do this challenge here with a playing card, okay? And so what the challenge is I stacked some pennies underneath, and I am going to stack some pennies on top. And the challenge is to see how many pennies you can stack on top and then flick the card out, okay? So when your friends are coming up to you, saying, hey, let's do this challenge, this is the trick. Make sure your pennies are lined up, okay? So first, underneath here, I'm looking, and those pennies are pretty well lined up. That is very important. Now I've got a small stack of pennies on here. The challenge, when it's you and your friends, see how high you can get that stack with still having that card be able to flip out and keep that stack standing. The point is to flip the card out from underneath the pennies, and the pennies stay stacked, okay? So this is a fun one to do with your friends at lunchtime. All it takes is some pennies and a rigid paper, okay? So just some paper that is thick enough that you can flick it out of there, okay? So am I going to be able to do it first try? I don't know. It's a challenge. That's how that works. So let's see how I do. I'm going to flick this thing here, and we're going to see if we can keep those pennies stacked. I'm not sure how many I have there, but you just need to make sure you can do one more than your friends can, because that's all that really matters. Okay, so I'm going to try and flick this thing. Here we go. Ready? 1, 2, 3. Oh, I knocked them down. So that's that challenge there. I'm going to try it again. Okay. Does that mean I'm going to get it? Nope, but I'm going to try it. And that's the fun of this challenge, is doing it with your friends. This one here is a science challenge, and you can tell your friends that you know the science behind this challenge, and that is the laws of motion. This thing is tending to stay in place because of the weight of those pennies. I do have other coins here. You can try putting another coin on there. If you're a crazy penny stacker, you can put different denominations of and weights of coins, but I'm going to try it out again. Here we go. Ready? And 1, 2, 3. Oh, almost. Now that's the fun of this one. I couldn't even do 1, 2, 3, 4, 5, 6, 7, 8, 9 pennies. Okay, but I want you to try this one. If you are watching, send us an email or make a comment and say, Mr. Dave, I can do 35 pennies. And maybe you can because you have way more talent than I do. So this is a fun challenge, and it is the penny stacking challenge, and that is to see how you can do this inertia little challenge with your friends using science and in a fun way that you can show your friends you're just a little bit better at it than they are, because that's the important part. So let's go over. We had rule number 1, an object in motion tends to stay in motion. And an object at rest tends to stay at rest unless something is applying a force to it. Object number 2 is the mass, right? That is the weight of something, and the velocity will show you how something is going to react. So if something has more mass, then it's going to be able to react to something with less mass and knock it far away. So I've got the world here, okay? So we're going to look at the world. I have the entire world right here, and the world is pretty heavy, but this one here, not so heavy. So this world here, I'm going to set right here, and I am going to blow up a balloon, okay? Now, a lot of my demonstrations, I use balloons. Balloons are disgusting. Yeah, when I'm asking about doing some science with a balloon, what is in a balloon, you're going to say that it is air. It is actually Stinky Dave breath, okay? This balloon is filled with my breath. Happy birthday, here's a sack of my breath. I don't know why we do that. It's disgusting. But this balloon here has very little mass, okay? This has got more mass. Our ping pong ball, that's got more mass. So when we take something very light and we throw it at something that is much heavier, my balloon's gone. That's why I have two. When we throw something light at something heavier, we will have a hard time moving the heavier object because it is going to want to stay at rest, correct? So I'm going to get my baseball. There's my baseball. And we're going to see if this little balloon will move this baseball. Now, the balloon is much larger, but it doesn't have much mass, okay? So here we go. We're going to try with the balloon, and yep, not a lot of movement there, right? We had a lot of movement with that balloon. I threw that balloon. It had a lot of motion, but it didn't have much velocity because a balloon really weighs very, very little. Okay, so remember when we are using balloons later on when I'm asking you what's inside of a balloon, because you're going to want to say Stinky Dave breath. All right, so we saw that this ball here tended to stay at rest. Okay, we saw that this ball has got a lot of velocity. Now I'm not going to throw this ball at something because I am an old guy and it will hurt my shoulder. No, because this ball is going to do some damage. This is a nice big hard ball. So what we're going to do now is we're going to talk about that third law. Okay. The third law of Newton's laws of motion is that every action has an equal and opposite reaction. Okay? So the next demonstration that we're going to do here actually has to do with quite a few laws because, as I said, our laws, you can imagine them to be kind of like our crayons or our paint palette. As we mix them together, we get different results, okay? If you mix blue and red, you're going to get purple. With these laws, we're going to get different results as we mix them together. So I'm going to show you this next one here, and it's going to actually incorporate a couple different laws, and we're going to talk about those laws, okay? So what I have, we'll start with this right here. This is a cup of Steelies. Yes, I call them Steelies because that's when way back in the dark ages, we used to actually play marbles, okay? And we had glass marbles and we also had Steelies, okay? These Steelies, you could knock them in there and knock those things all over the place, do all kinds of crazy things because they would just go all over, okay? So this Steelie here is very small, okay? It's much smaller than our planet Earth. It is much smaller than our, our planet Earth. But this Steelie is very heavy for its size, so it has a lot of mass, okay? And we're going to talk about that. Every action has an equal and opposite reaction, okay? So I'm going to put these Steelies down here. Now, you've probably seen this particular demonstration in a thing called Newton's cradle, okay? And what that is that's where we have the Steelies, or the steel balls that are on strings or ropes. And when you pull one out, it goes tick, 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 tick. Okay? Now, you may not see a lot of movement with these ones on the inside, but that energy that's there is being transferred from ball to ball to ball to ball to ball, and it will knock that last ball or this ball, because it can't transfer the energy, it's going to use that energy and it's going to move. Okay? So our energy, as we're rolling this ball here, is going from this ball, and then moving each of these very slightly, and it will show us at the end here what is going to happen with that energy as it's being spent going this way. Okay, so you've probably seen this one before, but this is just a begin to what we're doing with the rest of our demonstration. So I'm going to see if I can roll this one straight. This one's kind of tricky. Let's see if I can get it here, and yeah, there you go. So what we saw here, very simple, is that these ones here, these move because I didn't quite hit it exactly straight, but we saw that last ball go very far. Okay? Our other balls hardly moved at all because that energy was able to be transferred to the next ball and to the next ball and to the next ball. Okay? So with these steelies here, we can actually take them and as we're pouring them, okay, you can see that we've got kind of a gap in between them, but our velocity, right, the higher I get here, the faster they're moving. And so they are changing our mass from this cup into this cup. And those steelies are making this cup nice and heavy and this one very light. What's happening is that's the same as comparing our ping pong ball and our golf ball. Okay? Our golf ball is like this cup. Our ping pong ball is like this one in that even though they're roughly the same, on the inside there is a lot more mass. And so that means if I were to hit this cup with this one, we would get some easy motion. If I were to hit this one with this one, nothing. Okay? So we've got one more little thing we're going to do, and it's kind of a two-parter. And so instead of these big old steelies, we're going to go with some little bitty guys, okay? These little bitty BBs that are in this cup here are going to give us a little bit different part 2 newtons. This is a combination of all 3 laws, and we'll show you in just a moment. Now, I have our little BBs, and I also have a piece of tape, okay? So what we're going to do is I'm going to pull this out, and we're going to notice something. As that's flowing out of there, we can actually see it leaping from the cup, and we actually see it flying through the air there. So it's actually going in through the... Oh, I got BBs everywhere. And for my next trick, I'm going to disappear. No, I'm kidding. So they're on a string is what was happening there. But you'll notice, even though they're on a string, what makes them leap through the air? They didn't just pour like a liquid. They actually went through the air. They actually jumped as they were moving from the cup to the ground. So we see that fountain flowing. And I'll start it here again. I won't get them all, but I'll get it started just so you can kind of see the end of it. What's happening is the same as happens when you are trying to do an ollie. So I will show you the science of the ollie in just a second here. So I'm going to pull this one down. Oh yeah, and as you see, that's flying through the air there. Okay, that's the same as if you were to do an ollie on a skateboard. Okay, so very quickly here now, when me doing an ollie on a skateboard results in me hitting the ground. But what's happening with all of those little beads is as I pull on the one side, okay, just like when you're pushing that force down, you move your feet, you push your force down to do that ollie. When you push down, the same is happening. It's twisting those beads. When it hits that next bead, just like when this hits your surface, then you cause a little bit of reaction. Every action has an equal but opposite reaction. That reaction actually kicks it up just like it does when you're doing an ollie. And the same as when you slide your foot forward to pull that tail up, is that next bead is pulling down. So if you imagine that fountain is the same as our ollie on a skateboard, you can actually see that same motion there if you're imagining this to be the ball. So this is our ollie, right? All right, so those are our 3 laws of motion. An object in motion tends to stay in motion. An object at rest tends to stay at rest. The mass and the force, or mass and velocity, equal the force. And every action has an equal but opposite reaction. All right, guys, thank you for watching. I am Mr. Dave with the RayKitty Science Project. And remember, as I always say, science shows you matter.